Welcome, everyone. Today we explore a groundbreaking approach to visual programming, a tool that empowers you to build complex math and machine learning models using simple drag-and-drop blocks. Introducing Blockly, the AI editor that transforms coding into a visual experience. This innovative platform enables you to create advanced math formulas and train machine learning models without writing any code. With Blockly, creativity meets efficiency. You can construct logic visually, develop and train machine learning models directly in your browser, and perform sophisticated math operations with ease. Enjoy a workspace where advanced computations and intuitive design work in perfect harmony. In today's session, we will explore various aspects of visual programming. We begin with basic arithmetic and matrix operations, progress to tensor manipulation and neural network construction, and conclude with practical projects including linear regression and MNIST classification. Experience arithmetic and matrix operations in a completely visual format. On this platform, you can perform simple arithmetic, create and manipulate matrices, and execute advanced operations such as transposing matrices, calculating inverses and dot products, and solving linear equations. The next slide will showcase these capabilities in action. Here, we have three demonstrations that progressively build upon each other. First, we see a simple arithmetic operation, adding two numbers visually. Next, we extend this concept to matrix manipulations, where we create a matrix and compute its transpose, laying the foundation for more advanced linear algebra operations. Finally, we calculate the mean of an array, demonstrating how data aggregation works in a no-code environment. These visual building blocks simplify complex computations, making it easy to grasp core mathematical and machine learning principles. Transitioning to tensors and machine learning, this platform allows you to create tensors of any dimension and carry out operations such as slicing, joining, and performing arithmetic calculations. You can also build neural networks from scratch, configuring layers, selecting activation functions, and visualizing your model architecture, all while monitoring training progress in real time. Building upon our earlier arithmetic and matrix operations, we now introduce tensors, fundamental components of deep learning. In the upper section, we create a 3x3 tensor, visually defining its structure and values. Expanding on this, the lower section demonstrates an essential tensor operation, element-wise addition. Here, we take two tensors of identical shape and compute their sum, illustrating how numerical computations scale seamlessly in a visual programming environment. This progression lays the groundwork for more complex tensor manipulations, leading us toward neural network construction in the upcoming slides. Now, we apply these concepts with a hands-on project in linear regression. Using today's dataset, we will demonstrate how visual programming can transform raw data into actionable insights, simplifying even the most complex algorithms without traditional coding. We start with our data, input X and target Y. We initialize our model, then use our gradient descent block, running it for 1,000 iterations to learn. Inside, calculate gradient calculates the necessary updates. We then adjust our model's weights and bias using our learning rate, effectively training it. We track the mean squared error, or MSE, to see how well it's performing. Visually, we can see the data, the calculated MSE, and the final predicted values. Notice how closely our predictions align with the actual values. Blockly makes complex machine learning concepts accessible and visual. In the next project, we explore MNIST classification. We will build a neural network that automatically recognizes handwritten digits ranging from 0 to 9 using the iconic MNIST dataset. This demonstration clarifies the classification process and highlights how a no-code approach streamlines the task. Let's dive into MNIST classification with Blockly. We start by loading the handwritten digit dataset and preparing the images for our model. Then, we visually build a neural network, flattening the input, adding dense layers, and setting our output for 10 digits. We configure the training process, a crucial step. We select the Atom optimizer, known for its efficiency, and choose categorical cross-entropy, ideal for multi-class problems. We set our training to run for 10 epochs, allowing the model to learn from the data multiple times. We use a batch size of 8, processing small groups of images at once. As the model trains, we watch the accuracy improve with each epoch, giving us real-time feedback. Finally, we evaluate the trained model on unseen test data to check its generalization. We then generate a confusion matrix, a detailed table showing how well the model classified each digit. This visual representation helps us understand the model's strengths and weaknesses. Effective model development includes real-time monitoring. The platform's integrated visor allows you to observe training progress, giving you the flexibility to expand or minimize the view according to your preference. This feature ensures you remain fully informed about your model's performance throughout the training process.